In this video, we're going to do 9.0 in city state. So we're starting a new section, the 9.0 section. And this section has to deal with nested structures, references to nested structures, and any sort of helper function that emerges from that. All right. And we're going to see what I mean shortly. All right. So this problem has two subproblems, problem A and problem B. Let's just get started with problem A. So finish the uncompleted steps X of data design above for both address and person. So basically these steps, right? 1B, you see these two X's, right? 3 and 4, right? The data description and the interpretation is already done for us like so. All right. So just a quick reminder again that we should blaze through these steps. These steps shouldn't require all too much thinking. It's really coding the body and picking out the right template from the data that requires a lot more thinking. Likewise, writing some tests because you might miss some test cases. Anyways, I'm just going to zoom through those. All right, I have the steps here off to the side so I don't have to keep scrolling up and down and lose track of where we are. Okay, so let's just finish the uncompleted steps for designing data for address. So data description, let's see. Define struct address is in a structure that holds a city and a state, and those two are both strings, like so. The interpretation is an American style address. Fields are self-explanatory, so that's done. 1B, if using define struct, write all the accessor signatures. So let's just do that. So by virtue of define structure, right, we get these signatures, the functions built in address, city, that consumes an address and produces a string, and address dash state, which consumes an address and produces a string. So that step is done, easy peasy. So I'm going to check myself off for that. All right. Next is the data examples. So let's come up with some examples for this data. So I'm going to do some famous cities because they're easy to remember. Define address, good US city, common US city, Angeles, California. That's one city. I'm going to copy and paste this. And we're going to do SF. Whoops. SF. San Francisco. Let's see, San Francisco. That's also in California. Let's do a non-California state. So define NYC, make address, New York City of NY. String NY, my bad. There we go. So that is the data examples done. Easy peasy. All right, now next is a function template that processes this data. So that's simple enough. So we're going to have to write a template. Let's call it address temp that consumes an address, and we don't know what it produces yet because it's just a template outline that we're going to copy and paste from. So let's call the input parameter AD. We're just taking two letters off address as the name for the input variable name. All right. And then what we're going to do with it is that we have to remind ourselves that we can take it apart. So address dash state of AD and address dash city of AD, like so. All right, I'm gonna check myself off for that. Easy peasy. Now we are gonna do the same, but for person. All right. So for person is a defined struct with f name, l name, and then address. So this is a nested structure, right? This is a reference to the address data definition. All right. And first name, f name means first name, and L name is the abbreviation for last name. Address is an American style address, and it is a reference to this like so. All right. So that's going to make a little difference. Anyways, let's just do the steps for these. So after using define struct, write all the extra signatures. All right. So by virtue of define struct person, we get person dash f name, if I can spell that right, consumes a person and produces a string. Person dash L name consumes that person and produces a string, and person dash address, which consumes a person and produces an address structure this time. Okay, gonna mark myself for that. Easy peasy. Okay, gonna get rid of that X there. Next are the data examples. Okay, so let's come up with just one person for now is good. Define Bob, we'll say make person Bob, first name, his last name is Smith, and then he lives in LA. All right, this is the reference to the LA structure. All right, so I'm going to mark myself off done for the data examples. Next is a function template that processes this data. So this is where it gets a little interesting. All right, so give myself some space here. So define person temp, right? And we're going to name it PS because that's just 2 letters from person. For the input variable name, let's write the signature for this also. So person temp is a template that consumes a person. We don't know what it produces yet. We're just outlining what we have. All right, and we should take it apart. So we have person-f name consumes the given person PS, person-l name, and then person-address PS. All right. So since this references a non-base type, right? So we have define struct person address, define struct person, which has an address, right? This address is not a base type, right? And my base type, I mean, let's see, base types are numbers, strings, booleans, and images, right? They're the built-in types to Racket. Address is a type that we defined ourselves with define struct. So the rule of thumb that we're going to do is that when we see this, right, a reference to a non-base type, right, what we're going to do is we're going to wrap it in a helper function, right? The template is going to be wrapped into a helper function, which is going to be a reference to address temp, right? So going to wrap that into address temp, right? We don't know what it does, but we just know that we probably want to hand it off to a helper function like so. And that is the big difference here. All right. And I'm going to check myself off for that. All right. So we're done with all these data design steps. Let's move on to problem B. I'm going to move this up so you guys can see the problem. Okay. All right. So it says design the function in city state that consumes a person and an address and produces whether or not the given person is at the given address. And they already gave us the signature here. So let's just follow the function steps. I have it off here, off to the side again, so I don't have to scroll up for them. All right, so let's just run through this. So the signature is done. Next is the purpose. All right, so let's just do that. So design, well, whoops, I'm reading the problem statement in my head. Let's see, produce true if the given person is at the given address. All right, so that is the purpose statement done. Signature purpose, we still need the stub. So define in city state because we're taking in 2 arguments, person and address, so just call them PS and AD like we did for the templates above. And it produces a boolean, so let's just give it a dummy value because this is just a stub. We're going to run it against the examples. Okay, so I'm just going to give myself a check mark for that. I need to take one though. So like so. Cool. All right, so next are some data examples. All right, so check, expect, in city state Bob. Is Bob in LA? Yes, he is in LA, right? Because this is his first name, last name, and then the third structure field address is LA, right? Does this make address field? Like so. So it should produce true. Let's do another example. Check, expect, in city state is he in SF? No, he's in LA. Let's do one last one with our other example, right? So in city state takes in a person, and then we're going to give it another address, and that is NYC, but he's not in NYC, he's in LA. Like so. All right, so that is the signature purpose stub. Examples are all done. Let's run it to make sure everything is syntactically valid. And it is. Actual value differs, but it's fine. These 2 are passing because, you know, we're just spitting out false, but that's fine. Anywho, just going to mark myself done for the examples. All right. And I'm going to comment out the stub. Next, we need the template from data. All right, so we scroll up, we've written some templates that we could use as starter code. And the one that we're going to use is either person or address. Probably this one, all right, for obvious reasons. So I'm going to copy and paste it down. I don't need the signature because we wrote the signature here. And I'm going to paste this down like so. Rename this to in city state. And it takes in 2 arguments this time. That's the number one mistake that people make, right? They don't match the signatures correctly. So it takes in 1 argument. First argument is person. Second argument is the address. So AD, I think that's what we called it. Yes, we did. Okay. That's the name of the parameter we called. All right. So that is the template from data done. Next is the hardest part. All right. Code the body that fulfills these tests with the given template. All right. So first name and last name aren't really relevant to this problem, right? It's going to produce true or false, and we're not. Bob's first and last name is irrelevant to this problem, only his address. So we don't need this and this, all right? And likewise, we probably don't need an operation outers here too. All right. So what we're going to do is, since we're calling the helper function, we're going to make a work order, right? We're going to make a wish list / work order, and we're going to say, hey, I wish I had a function that compares addresses, right? And those addresses are Bob's address. So this is Bob's address, right? It's person-address. And we're also given an address, AD here, which we're going to pass in, all right? So now we have a work order of a function that we need to create, all right? Right now we're pretending it exists, right? Now we actually have to go write it, because if we run it, it's going to say, hey, it's not defined yet, all right? So anywho, let's just do that. We're going to do that and write the steps. We're going to do the function design steps for this new address equal function, all right? Because it's, when I was writing this function, right, it's easy to sort of think how it decomposes from the top down, right? Because I'm writing address equal and that's the functionality I want, but it doesn't exist yet. So sometimes it's easier to think in terms of just writing the name of the function first before defining it. Anywho, let's just go through the design steps for address equal So address equal that's the signature for it. It's going to consume 2 addresses and produce a boolean. All right. Produces true if the 2 given addresses are the same. All right, so what do we mean by the same? Well, let's just clarify it some more. Addresses are in the same city and state. Okay, so signature, purpose, stub. So let's stub this out. So define address equal takes in 2 addresses, so we'll call it 81 and 82, right? And then produces a boolean. So we'll just use false as a dummy value. Next are the examples. So check expect. And we're going to say address equal Does LA equal SF? No, they don't equal, right? They're in the same state though, right? LA is in California, SF is in California, but the cities are different, so this should produce false. Let's do another test. Check expect. Let's say address equal LA and NYC, also false. But when should this function be true? Well, it should be true in the case of address equal LA and LA. All right, and both the city and the state are true is when this should produce true. So let's just run this against the stub. Mismatches, that's all fine. So I'm just going to check myself off for all the steps I did. Signature, purpose, stub, examples. All right. And let's comment this out. Now let's grab the template from address, right? Because it consumes 2 addresses. And we have a template that we can use as starter code that consumes an address. Like so. I'm going to copy this down, paste it down here, and use this to kickstart our development. All right, going to rename this address going to make sure the signature matches. This takes in 1 argument. This takes in 2 arguments. So I'm going to call this 81 and 82. I'm going to rename these 81 as well. All right. So that is the template mostly done. We noticed that we have an address 2 here, so we got to do some more here, right? Like address 2 and address 2. Okay, so that is the template mostly done. Gonna give myself a check off for that. Now code the body. All right, so what do we have to do to make this function fulfill these tests? Well, city and state, right? State and city are both strings. This is going to get the state for the first given address, and then this is going to get the state for the second given address. And they're both strings, so we need to compare them with string equal ha. All right. Likewise with this second one, they're both strings, so string equal ha. And then there's, since this produces a Boolean, right, you have to look through the racket, help desk for which functions consume and produce Booleans. In this case, I know that we need an and here because we want to make sure that both of these are the same, right? The state and the city have to be the same in order for it to fulfill the examples over here. Because again, LA and SF are in the same city, but they're the same state, but they're not in the same city. Anyways, if we run this test, it should pass this test. And since all this function does is call the helper function, it should also finish these tests like so. So I'm going to run it here and all 6 tests pass. All right, so you might be wondering, why do we have you write a helper function here, right? Can't we just do this inline? And let me just type that out inline, just show you guys what it'll look like. So I'm going to copy and paste this function like so. And I'm going to call this in city state. Inline Dixon PS and AD. All right, we don't need the first name and last name. We're going to pretty much not call a helper function. We're just going to write it all in this one function. So, and, right, we're going to need the address, address city of the given person, and then the address state of the given person. All right, we're also going to need to wrap these into string equal ha. And then we're going to take the address, the given address, right? Because the first argument is the person, and the second given argument is if this person, lives in the given address over here. So we're going to get that out. So address dash city of the given address that we want to find. And then we pretty much want to do the same thing down here. State this time. And then we're going to wrap that around here. All right. So this one and this with calling a helper function, right? Which breaks things down into more smaller tasks that might be easier to think about. They do the exact same thing. In fact, I'm going to comment out the one that we wrote with the helper function and run this one instead. And you're going to see that it passes the test exactly the same way. All right. But why are we having you write it like this with a helper function call? Well, it's because there's duplication here, right? So we take address dash person PS and then address dash person PS to get the address out of the person and then feed it into address dash city and then address dash state. So this one and this one, right? There's 2 calls here, there's duplication here, and there's more nesting here. So it gets kind of confusing and it's not as clear as the calling the helper function version, right? So that's what we're going to have you do going forward. All right. Whenever you see a reference to a non-base type, right? This structure has a string, and then this new type that is a non-base type. It's not a number, it's not a string, it's not a Boolean, it's not an image. It's a new struct that we invented. It's a new type that we invented. We're going to ask you to write your templates such that it calls a helper function like so. All right. It reduces duplication and it'll make, problems easier to decompose and think about going forward. Because this is just a simple case of, small structures. We're going to have a lot of bigger structures and it's going to help us with better design and legibility. All right. So the future problems 9.0 are going to be a lot similar to this. So I highly recommend you use this as a reference video. All right. Anywho, all that is left is to test, review, and refactor. It doesn't look like we can review and refactor much. I'm going to hit Control-I to re-indent anything. Save this file, and then I encourage you to hand it in, select the right slot, and check your score on the website. All right.